So, hello everyone. So I'm trying to give a short wrap up on the lecture introduction. I've done something like this during my regular lectures, and I want to try out if it also works um, in the offline modus. Um, I always found it may be interesting for the students to get a short summary of the lecture, which provides you with another view on the material, and maybe it's helpful, maybe not. If you don't find it helpful, of course, you don't have to take a look. So in the introduction, we talked about the big picture on learning, um, and I'm not sure how much you can grasp, but maybe you at least hear some keywords, and later you feel motivated to look up some of these things. So we started off with saying that machine learning is really one of the important mechanisms uh, for living beings. Any living being seems to have learning capability, and if you consider the other two as being um, um, natural selection and design by engineers, learning is, I think, on the same level of power, of abstraction, and of effectiveness in producing functional solutions. And of course, in the area of deep learning, this even increases a lot. So we looked at a little at the philosophical history, and there is a lot has to do with the dichotomy between top-down approaches, for example, in rationalism, and bottom-up approaches in empiricism. And this is reflected in the history of philosophy. Of course, occasionally other things came in, like idealism, where more the idea matters. Currently, we talk about idea of freedom and others, and so in some way, these idealistic ideas are still quite powerful and dominate a lot of political thinking. Positivism was a neo-positivism was the attempt to bring scientific rigor, also mathematical approaches into philosophy. But then, of course, there were reactions also from other sides, which, particularly in terms of how society was, might not have too much to do with scientific approaches to physics and chemistry. So Popper probably brought it best to the point that we have to live with empiricism because that's the only source of knowledge. And but then we have this dilemma that it's not sound. We cannot really prove something about the world, and he introduced this concept of forcibility, falsifiability, that if you should come up with reasonable theories which can be falsified, and if they are never falsified, then maybe you can start having enough support to assume that they're correct. Then there was psychology with also two history traditions um, in cognition and in behaviorism. So behaviorism very much emphasizes that we should have scientific approaches to studying animals and human beings, and not so much look into the inner working of the brain, whereas cognition thinks that the brain can be understood by mathematical means, and of course other parts of neuroscience entered the field. And I think now we are in the age where people look at all the different aspects um, of the different fields. On a cellular basis, learning appears to be happening mostly on the synaptic level. So, you have an input, many inputs to a neuron. They're called dendrites. They're activated by sensory neurons or other neurons. They excite the cell body, and if this goes over a certain excitation level, an axon is an action potential is fired, which travels along the axon, potentially very long distances. And here you have the synapses at the end of the axons, and which connect to dendrites of the postsynaptic cell. And at this level of this junction, learning is supposed to happen. So these the strength of these connections can be enforced or can be weakened. That was Hebb's hypothesis. Neurons that fire together, wire together. So here's his famous statement. Neurons that fire together, wire together, or neurons out of sync lose their links. So there's also a mechanism to decrease effectiveness of the synapse. Then machine learning also has a long history in terms of the technical side of learning or mathematical side. So before the computer age, there was essentially statistics, Bayesian statistics, and then classical or frequentist statistics. Then there was the first wave of the idea that the neural networks can be formalized in these simple computational units, and maybe they tell us something about how the brain works and also how learning works. So these are one of the first papers was, or the famous paper was from McCulloch and Pitts, who introduced this very simple idealized mathematical formalism for a neuron. And then also John von Neumann thought about this. And then the really interesting work was here from Frank Rosenblatt, who developed a learning algorithm to tune these synaptic weights, or these parameters in the simple neuron. And then there was another field called classical artificial intelligence. So it started sort of 57 and maybe went to the mid-80s with different sub-trends in the field. But essentially the idea was, maybe intelligence can be captured by mathematical models, by logic, first-order logic, and was in focus. And there was a lot of interesting ideas. So this is a reference to the 1957 workshop in Dartmouth, which is considered the starting point of AI. But this more formal, rule-based, top-down approach to intelligence had limited success and maybe promised too much in too short a time. So at least in the US, the funding sort of dried up in the 80s, and that gave neural computation another chance at getting funding and getting activity. So this is a phase I sort of experienced, at least the later phase. And the most important thing is the invention of the multi-layer perceptron by Rumelhart, Hinton, and Williams, which really enabled people to develop quite powerful neural network models, which were very competitive and found a lot of interest. Then there was a phase with mathematically founded models. We will discuss this. Then there was maybe null computation 3, at least in the way I counted, AI2, which is the time now that people focusing again on neural networks with very large architectures, and they give partially fantastic results. So this will be covered also partially in the lecture, but of course there's also another lecture completely focusing on deep learning. And yeah, so I hope you enjoy the lecture, and this was the wrap up of the introduction.